Okay, so this is going to be on how an internal combustion engine works. The tiny amount of energy, tiny amount of high energy fuel like gasoline in a small enclosed space, such as a tube ignited warm expanding gas. So that means the basic principle of how an engine works, right, is that you take the chemical energy from the gasoline and you light it, make it into thermal energy. Thermal energy creates pressure. Boom, you got that pressure and you can start pumping a piston, right? That's what it's going to get into. Oh, it's a 2-foot tube. You can use an energy to propel a potato 500 feet in the air. Because this is not a combustion they're talking about. This is potato gun now. So yeah, so again, it's taking the pressure, and this is all, again, conservation of energy. So it's transferring the pressure, the energy and pressure that's carried from thermal energy into, which, you know, pressure because of Boyle's law is the same thing. So shoots it out. And then they have an image here below. Okay, so it's pretty much just showing a potato gun. You got the picture here of how a potato gun works. Again, you just build up pressure in there and you can make it shoot. Alright. So 100 times per minute. Okay, now we're getting into combustion engine, the 100 times per minute. This is going to be talking about how a piston works, right? And how they use it to... yeah, so we're talking about how to use the car, almost. Gasoline. So again, all engines use it, so that's not surprising. Four-stroke approach is also known as the Otto cycle. I don't know the Otto cycle in honor of Nicholas Otto, who invented it in 1867. The four strokes are illustrated in Figure 2. The intake stroke, the compression stroke, the combustion stroke, the exhaust stroke. So, okay, so now we're going to go through hopefully what all these strokes mean. You can use Figure 3 to look at this. So let's take a peek here. Figure 3 you got. Okay, that's just a picture of a piston. Or I mean a combustion engine, but specifically of how the piston works within the combustion engine. Piston replaces the potato tube. Yeah, as mentioned earlier, the piston is connected to the crankshaft and by a connecting rod. Okay, so again, you got your crankshaft, get your connecting rod. That's going to create rotational energy. That's going to create that rotation there. So the piston pumps, and that starts to spin, and that's going to get everything spinning. So you're going to have that pressure pushing it, pop, 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 and it creates it circling, right? And that one's going to describe. Resetting the cannon. Oh. So it's actually, the idea is that it resets it, so it gets it down there. Sets the top, the intake valve, and the pistons move down to let the engines take the cylinder full of air and gasoline. This is the intake stroke. Intake valve opens. So okay, so you'll be letting stuff in, mixed into the air for this to work. Okay. Then the piston moves back and compresses the fuel and air mixture. The compression makes an explosion more powerful. So again, you're shrinking the energy, making all that, you're compressing all that energy, and it creates a little bit of a spark, and that pressure really makes the heat extremely hot. And so there you go. Oh, when the piston reaches the top stroke, the spark plug emits a spark to ignite the gasoline. The gasoline charged the cylinder explodes, driving the piston down. So again, so you're going up, it sticks in there, boom, and then it blows back down. Once the piston hits the bottom of its stroke, the exhaust valve opens and leaves the cylinder to go out the tailpipe. So again, so you have the exhaust valve for, you got to get rid of all that stuff, all the nastiness that's in there, so you have your exhaust. So it goes in, pops down, pops it down, presses it up, and you get your spark, you get your energy, you release the exhaust valve. Now the engine is ready for the next cycle, and it takes charge. Notice that the motion that comes out of the turbo engine is rotational. So again, this is what I was talking about. So you're going to be starting to get, I mean, if you think about an engine, it's going to be spinning around, right? So this is what it's getting into now, is that it spins around. Is linear. So yeah, so it just pretty much straight shoots it out. This one behaves will create the rotation. Piston is converted into energy by the crankshaft. That's what I was talking about. The rotational is nice because we can then rotate the car's wheels with it anyway. So again, yeah, I mean everything needs to spin in a car. I mean if you look at it, it's all things. I mean it's all you know, pulley. I mean not pulleys, but you know, oh my God, whatever. Bands, thank you, bands and things spinning, causing ultimately because you need the wheels to spin. And if you look at the parts that work together, this to happen, starting with the cylinders. The core of the engine is the cylinder. The piston's moving up and down inside the cylinder. So again, it's this sort of the circular thing. The engine described above, as shown in Figure 3, has only one cylinder. Now, of course, yeah. So I mean, most cars have what 4 to 8 of those. I mean, most typically 4. Typically, most lawnmowers, most cars have more than one cylinder. 4, 6, 8 cylinders are common. Multi-cylinder engine, the cylinders are arranged in one of 3 ways, in line, V, or flat. Oh, I didn't know about this. Also known as horizontally opposed or boxer. The different configurations have different advantages and disadvantages in terms of smoothness. Okay, so that's interesting. I wonder why that works. The arrangement of the cylinder would cause different things. Okay, I hate that they do that. So at the end here now, they have like a thing where they say essentially there's advantages and disadvantages to it, but they don't actually go into it, and it just kind of introduces it, and you're kind of left with, so what does that mean? So anyways, that's it. I hope that makes any sense at all. It probably sounds like me mumbling a lot. I apologize, but it is what